For centuries, Ceres was nothing more than a faint point of light through telescopes. It sat quietly in the asteroid belt, orbiting between Mars and Jupiter, a distant, icy body, too small to be a planet, too large to be an ordinary asteroid. But behind its quiet presence lay mysteries that would one day captivate the world. That day came in 2007, when NASA launched the Dawn spacecraft, a mission designed to do something no other spacecraft had done before: orbit two separate worlds in deep space. Powered by its advanced ion propulsion system, Dawn was capable of slowly building speed over time, allowing it to maneuver across vast distances with unmatched precision. Its first stop was Vesta, the second largest object in the asteroid belt. For 14 months, Dawn mapped Vesta's towering mountains and ancient craters, uncovering a world shaped by violent collisions and volcanic activity. It was a glimpse into the early solar system, but the true prize still waited farther out. After leaving Vesta behind, Dawn set its course toward Ceres. This dwarf planet, almost 950 kilometers across, is the largest and most massive object in the asteroid belt. Discovered in 1801 by astronomer Giuseppe Piazzi, Ceres has puzzled scientists for over 2 centuries. Was it a failed planet? A massive asteroid? Or something else entirely? By early 2015, Dawn reached orbit around Ceres, and for the first time in human history, we saw its surface in detail. What the spacecraft revealed was far stranger than anyone expected. Ceres was covered in craters and ridges, but scattered across its dark, rocky terrain were shining bright spots that reflected sunlight like beacons. The most famous appeared inside a Cater crater, a formation about 57 miles wide and 2 miles deep. Here, dazzling white patches gleamed so intensely that even low-resolution images had revealed them long before Dawn arrived. At first, no one knew what they were. Some thought they might be exposed patches of ice, others wondered if they were made of highly reflective minerals. A few even speculated about artificial origins, sparking excitement across the scientific community and beyond. As Dawn's cameras sharpened their view, the mystery deepened. Cater's central bright spot wasn't a single patch, but a cluster of reflective deposits, each with its own unique shape and brightness. Careful analysis revealed that these spots were made of sodium carbonate, a type of salt usually associated with liquid water. The discovery suggested that briny water had once risen from beneath the surface of Ceres, erupting or seeping into the crater before evaporating, leaving behind the glowing deposits we see today. This meant something astonishing. Ceres was not just a cold, dead rock. It was an active world, shaped by hidden forces. The presence of salts, water ice, and ammonia-bearing clays pointed to a history of internal activity. Scientists now believe that Ceres contains a large reservoir of water ice beneath its crust, perhaps even pockets of salty liquid water. If true, this makes Ceres one of the most water-rich bodies in the solar system. And with water comes an even more tantalizing question: could life exist here? While no direct evidence of biology has been found, Ceres has many of the key ingredients: water, organic materials, and energy sources. Its interior may still be warm enough, thanks to radioactive decay, to maintain subsurface brine reservoirs. If microbial life can survive beneath the icy moons of Jupiter and Saturn, why not within Ceres? Even its geology suggests surprising vitality. The bright spots in a Cater crater show signs of changing brightness over time, hinting at ongoing activity. This supports the idea that Ceres might still have cryovolcanism, volcanic activity that erupts water, ammonia, or methane instead of molten rock. Cryovolcanism would make Ceres not just geologically active, but a kind of time capsule, a natural laboratory holding processes that shaped the early solar system itself. If frozen brine still lurks beneath its crust, then every eruption, every salt deposit, is a clue to how water, chemistry, and geology have interacted over billions of years. Unlike distant icy moons such as Europa or Enceladus, Ceres lies much closer to Earth, making it a far more accessible target for exploration. Future missions could deliver robotic landers, autonomous rovers, or even drilling probes capable of penetrating beneath the surface, searching for brine pockets or organic molecules. In doing so, Ceres might become humanity's most convenient doorway to understanding habitable environments beyond Earth. But the story of Ceres is more than geology. It is also about origins and journeys. The discovery of ammonia-bearing minerals hints at an unexpected past. Ceres may not have formed where it now resides. Instead, it might have been born in the colder reaches of the solar system, farther from the sun, where ammonia and ices were abundant. Only later, through the slow migrations of planets and gravitational tugs, did it drift inward, settling into the asteroid belt. If true, then Ceres is a cosmic migrant, a traveler that carries with it the chemistry of another realm. Its surface and interior may preserve the fingerprints of planetary migration on a scale that reshaped the early solar system. The Dawn mission officially ended in 2018, when the spacecraft exhausted its fuel and became a silent satellite, forever orbiting the dwarf planet it unveiled to humanity. Yet its legacy is profound. Dawn showed us that Ceres is not simply an oversized asteroid or a downgraded planet. It is a dynamic, water-rich world, where ice, salt, and rock combine in ways that challenge our definitions of habitability. Its surface tells a story of impacts and eruptions, but also whispers of hidden oceans and deep chemistry. And perhaps most importantly, Ceres revealed a truth that extends far beyond itself. That even the smallest and most overlooked objects in our solar system can rewrite the textbooks of planetary science. What we once dismissed as inert may turn out to be alive with activity. What we once thought simple may turn out to be profoundly complex. Ceres remains a world of unanswered questions. Are there still liquid reservoirs beneath its icy crust today? Could microbial life be hiding within briny layers, shielded from radiation by kilometers of rock and ice? And if Ceres can harbor such environments, what does that imply about the thousands of icy worlds circling other stars across the galaxy? In many ways, the bright spots of Ceres have become a symbol of discovery. They shine across the darkness not only as geological curiosities, but as reminders that the universe is still full of surprises. Even within the familiar boundaries of our solar system, there are mysteries waiting to be uncovered, worlds waiting to challenge our imagination. Ceres is no longer just a faint dot in a telescope. It has become a living puzzle, a world of hidden oceans, strange lights, and potential secrets about life itself. It stands as a stepping stone, bridging our understanding of the solar system's past with the search for habitable worlds across the cosmos. The story of Ceres has only just begun. And when humanity returns, with orbiters more powerful than Dawn, with landers that can touch its soil, and perhaps with drills that can reach beneath its frozen crust, we may uncover answers we never imagined. Answers about life, about water, and about the very forces that shape the universe we call home.